Hi everybody, welcome to another video in Business Calculus, section 13.1, area between curves. We mentioned that on the previous section that area must be positive. So in that case, if we want the area between two curves, of course the function have to be continuous. If the function is not continuous, there will be no area. So we define f and g are continuous, and f of x is greater than or equal to g of x on all the interval from a to b. In that case, the area bounded by f of x and g of x and x between a and b is given by this integral. So of course the function that is above, or the function that is greater, minus the function that is below, or the smaller function. So this guaranteed to be greater than or equal to 0. Of course, we talked about earlier that dx is the width, and this is like the height of the rectangle, and the height cannot be negative. So that's why we require f of x greater than or equal to g of x. So f of x is the function that is above, and g of x is the function that is below. And we want the area from A to B. So notice that in this portion, the y equal to f of x is above the function y equal to g of x. But it doesn't have to be right where the intersection is. We can define the area between two curves when, let's say, we have A is this point and B is this point. So the area between two curves that area is given by the formula. So from A to B, the function f of x is above the function g of x, so we subtract them and integrate from A to B. So that area is given by that integral. So simple enough. So it's useful if we draw the graph and see what is the area we integrate. We need to know that what function is above and what function is below. Right, let's look at the first example. Find the area bounded by the graph f of x equal to 6x minus x squared, y equal to 0 from 1 to 4. Right? So 6x minus x squared, if we graph six x minus x squared, just look at the table first. When x equal to 0, y equal to 0. When x equal to 6, y equal to 0. So we have those points. Okay, 0, 1, 2, 3, 4, 5, 6. Because this is the graph, this one is a parabola. So there's an active symmetry. So because it's symmetry on 0 and 6, so that will be right in the middle. And 3, that will be 9. Right, so we have the graph. So 0 here and 6 there, and it go there right in the middle. When x equal to 3, it is at the vertex at 9. So we have the values. Right, 9. Okay, it's not enough, so we have to say 2, 4, 6, 8. So 9 will be right in the middle here. And when x equal to 1, it is equal to 5. Equal to 5 and 5. Right, so that's good enough. So the graph so this is f of x equal to 6x minus x squared. Right, 0, 0, 6 and 0, and then we have the graph. Y equal to 0, that is the x-axis. And now we want the area from 1 to 4. So 1 to 1, 2, 3, 4. Right. So we asked to find this area. Right. So simple enough. They say the area is equal to. We know it's going to be from 1 to 4. The function above is f of x. Just going to say 6x minus x squared. The function below is y equal to 0. Just do that. So we have from 1 to 4, 6x minus x squared dx. Right, the rest is simple. We just integrate. Integral of x is x squared over 2. And x squared is x cubed over 3. We will evaluate from 1 to 4. Right, 6 divided by 2 is 3. And this we can write 1 over 3. So we're going to have 3. 6 divided by 2 is 3. X squared, and then minus 1 over 3. X cubed from 1 to 4. Right, we're going to substitute 4 in for x. And then we substitute 1 in for x. So 4 squared 16, that's 48. 4 cubed is 64, 64 over 3. 3, 1 squared is still 1, so that's 3 minus 1/3. And put this together, we have 48 minus 64 over 3 minus 3 minus negative, that's a plus. So that gives us 48 minus 3 is 45. 64 over 3 and 1 over 3, that's 63 over 3. That's 21, right? So 45 minus 21 is 24. Right? And then we can confirm our answer with the calculator. Right? So it's useful to plot to see which function above, which function below. This one is easy. We know y equal to 0, and then the parabola up and down, so it goes like that. Right. Next. I'll find the area bounded by the function x squared minus 1 and g of x is minus 1 half x minus 3 from x equal to negative 1 and x equal to 2. Right, x squared minus 1. So clearly, if x equal to 1 or x equal to negative 1, y equal to 0, so I have 1 and negative 1. So let's say right. So if we have the graphing calculator, we graph that, but x squared minus 1, so and this one from negative 1 to 2, so let this be negative 1, 1 and 2, right? X squared minus 1, just it's going to be a parabola that open up. We can make a table for that too. We'll put small values from -1 to 2 because that's what the graph, what we only calculate from -1 to 2, right? -1 put in here, -1 squared is 1 minus 1 is 0. When we put 0, we have -1. When we have 1 in here, that is 0. And when we put 2, that will be 3. So the graph will go to this point. 3, so 2, 4, yeah, that will be 3. Right, so the graph go like this. And then next we have -1/2 x minus 3. So let's graph that. -1, 0, 1, 2. Right. When x equal to -1, put in here, that is negative times negative is positive, so -3. That would be, if we write decimal, to be -2.5. Put 0 on there, that would be -3. Put 1 in there, -3.5. And put 2 in there, 2 and 2 cancel out, that's -4. Right, so just plot those points, -1, okay, -1, -2, -3, -4, wait, here. Right, -1 is -2.5. At 0 is -3. At 1 is -3.5. And at 4 is -4. And we want the area from 1 to -1 to 2. So we'll go from -1 to 2. So we're talking about this area. Right. So the area is from -1 to 2. So we're going to take the function that is above. So clearly it's going to be the x squared minus 1. And subtract the function that is below. Right. So we just have from -1 to 2. X squared minus 1 minus that plus 1/2 x minus that plus 3. So x squared plus 1/2 x. -1 plus 3 is plus 2. We integrate. So it's simple. This power rule. That gives us x cubed over 3 plus 1/2 x squared over 2 plus 2x, going from -1 to 2. Right, let's simplify this a little bit. 1/3 x cubed plus 1/2 the 2 at the bottom. So 2 times 2 is 4. So 1 over 4 x squared plus 2x from -1 to 2. Right. Now I'm just going to use the calculator. Let's do star to x. Sorry. Back to home screen first. 2 star to x. and then we're going to just enter this in 1 over 3 x cubed plus 1 over 4 x squared plus 2x. So at x equal to 2 we have that, we can convert to fraction 23 over 3. And now we store -1 into x and evaluate the same function. And we can convert that to fraction as well. -25 over 12. Right. So basically we have this fraction subtract this fraction. So that's 39 over 4. Right. So of course we can substitute and evaluate by hand, but that should give us the same thing. Of course we can check from the beginning, from -1 to 2. And here just say x squared minus 1, x squared minus 1, subtract 1 divided by 2 is just 0.5x minus 3, close dx. Right, that's what we have. Simple enough, right? So we draw the graph so we know which function is above, which function is below, so we can subtract them. Right, next, I'll find the area bounded by the graph x squared minus x and 2x from -2 to 3. Well, so of course we kind of make a table like that. X squared, so it's going to be a parabola, 2x is going to be a straight line. So from 2 to -2 to 3. So make a table. Let's do x squared minus x. I just put a few points at -2 and then of course later on 3. I choose those points. -2, we need from -2 to 3, so that's why we have those points. Right, from -2 to 3. -2 put in here, -2 square is 4 minus, so that could be 6. -2, 1, 2. Okay, let's just see how to go. First put in 0, we have 0. Put in 1, 1 minus 1, so that also 0. And put in 3, 3 square minus 3, so that also 6. So from -2 and 3, that's going to be just 6. Right, so this is -2. This is 3. 0 is 0. And 1 is 1, right? So when x equal to -2, y equal to 6, 1, 2, 1, 2, 3, 4, 5, 6. And 3 of also 6. And 0, 0, 1, 0. So the parabola goes like that. And now G is derivative of x is 2x. Yeah. For this is the equation of a line. We just need 2 points. When x equal to -2, that's -4, and when x equal to 3, it's going to be 6. Right, so we do have go to that point too. 1, 2, 3, 4. This is -4. And it go to 0, 0 if we can confirm that, of course. And so we want the area from -2 to 3. Right, now what is the area? The area between the two curves, right? So from -2 to 3, notice that from -2 to 0, the curve is above the line. So we're talking about this area. And then from 0 to 3, the line is above the curve. So we're talking about this area. So it is the area between the two curves. It did not say below what curve or above what curve. So that's what we have. So that is the area. So there are 2 parts. This part, the area from -2 to 0, the function above is going to be x squared minus x. The function below is 2x. So that is this area. And this area will from 0 to 3. The line is above. Subtract the function below x squared minus x. Right. So from 0 to 3, we have 2x. 2x minus a negative x, so that will be 3x. Minus a negative x. Minus x squared. And this one from -2 to 0, x squared, negative x, negative 2x, that's -3x. Right, just evaluate them. Of course, we can do this by hand, but on this one, I'm just going to use the calculator. From 0 to 3, 3x minus x squared dx. That 4 over 5 is 9/2. And now the other integral from -2 to 0, and we have x squared minus 3x. And convert that to fraction, 26 over 3. And add these two together, the total area (79 over 6). Right, so that's nice and all, but it can get even better if we have the calculator. We can just say from -2 to 3. Now if we write that, we don't really sure which function is above, which function is below. So in that case, we find the absolute values that guarantee to be positive. So that is a way to do that without knowing which one above, which one below. We just put in the absolute values. Of course, that doesn't change to fraction, but to say, if we take 79 divided by 6, yeah, the answer is, this is our answer, exact answer. The answer on the calculator get, it is an approximation, so there's some error in the approximation here, but they should be the same. Right, that was where we have absolute values. The calculator only calculates approximation, so it's not the exact answer. So that's why we have the difference of the two, but we can see that they practically the same. Right, so with that, I finished section 13.1 here. As always, thank you for watching, and see you in another video in business calculus.